I greet you, ladies and gentlemen, as I begin this lecture, which serves as an introduction to the two interfaces or software packages that you are likely to use when you are analyzing your data. One software is the Eviews software, which is normally used to come up with econometric models for purely quantitative data, which is normally imported into the software interface via Microsoft Excel. And then the other software, which is normally used by students to analyze qualitative data, is called the Statistical Package for Social Sciences, or SPSS. So the PowerPoint presentation that I'm going to use, or that I'm going to present in this exposition or in this lecture, serves as an introduction to those two interfaces. And then in subsequent lectures, I'm going to demonstrate how you actually analyze data in practice, first using SPSS, and then in a later video, I'm going to also illustrate how you analyze data using Eviews. So without wasting a lot of time, I'll go straight to my set of slides. So as we can see, this is a research methodology course that I came up with to assist us in understanding how you use the two main software packages to analyze data in order to fulfill the requirements of dissertation, the requirements of the dissertation, which is a component of master's degree programs. And the notes that I'm going to present are also applicable to undergraduate studies or undergraduate degree programs. I specifically came up with this compilation of slides in preparation for my data analysis component of the research methodology course for master's degree students. But over the years, the same kind of presentation has been used by also undergraduate students or bachelor's degree students. They've benefited quite a lot. Data analysis has to take into account the three types of research designs. We have got basically qualitative versus quantitative research. We also have mixed methods where qualitative data is gathered or used, as well as quantitative data. With qualitative research, generally it involves exploring and deriving understanding when it comes to the meaning of individuals or groups that ascribe to a social or human problem. So we'll be looking at how we can gather qualitative information pertaining to individuals or groups within a social construct or within society, or within a context related to a human problem or human problems. Quantitative data has a lot to do with testing objective theories by examining the relationship among variables. A case in point is when a person is examining the impact of changes in interest rates on gross investment in an economy. There's nothing qualitative about such an investigation. It's one quantitative variable juxtaposed against another quantitative variable. So the relationship is purely quantitative. And then mixed research methods, it's an approach to inquiry or investigation that associates both qualitative and quantitative forms of data. The aim, again, will be to, to tap into the strengths of both methodologies, that is qualitative research and quantitative research. When we look at quantitative data, it's normally presented in a numerical format, and it's collected in a standardized manner through surveys, closed interviews, tests. It's analyzed using statistical techniques, and quantitative data in a numerical format may be presented either through graphs or through, tabular means, and it can exist in secondary documents, which may be part of textbooks or journal articles, where such data can be gathered or can be compiled by whoever is analyzing the relationship or the relationships that exist between certain variables or among certain variables. And quantitative data can also be gathered from quarterly digests of statistics, as well as other schedules that are published by official bodies, such as the Central Bank of a country, or even multilateral institutions like your International Monetary Fund or the International Bank of Reconstruction and Development, which is commonly known as the World Bank. They also publish, copious volumes of secondary data of a quantitative format on nature. And then when we look at quantitative data, we gather in extension are more generalizable than quantitative data. So when you look at the qualitative data that we gather, we realize that it's easier to generalize quantitative data, I mean to say, compared to qualitative data, because qualitative data has got both, subjective and non-subjective elements to itself, whereas quantitative data is just objective. It will be figures or certain attributes of figures, calculated attributes of figures like your correlation coefficients, your standard deviation, and so on, or your range, either your measures of central tendency or your measures of dispersion. When you look at qualitative data, it's normally gathered through surveys. For instance, reporting how many people answered A, B, C, T, the average number or score, a change in score between 2 points in time, how many people compared, and so on. The qualitative data can be gathered through surveys. And then a preliminary process which is involved in data analysis is to have a plan. Without a plan, otherwise data analysis is not possible. When someone gathers data, whether qualitative data or quantitative data, one has to code it, because it's highly unlikely that the gathered data will come in a form or in a format that can be readily analyzed. So it's the duty of the researcher to compile the data, codify the data into codes that link with the research topic or with the aspects that the researcher wants to analyze. For instance, you can have a schedule of figures which is written interest rates, and the other column may be national income aggregates or GDP at market prices. Ways written interest rates, maybe in terms of your model formulation, it will be R for interest rates. And ways written GDP at market prices or gross domestic product at market prices, it might stand for the model formulation Y or just GDP. So it would be necessary for the researcher to quote those different variables so that the information can then be programmed into a specific model. And then after quoting and entering and cleaning has been done to remove outliers and also to take care of other issues associated with the compiling data. The information is analyzed. After analysis, the data is interpreted, and then we reflect on issues such as what do we learn, what conclusions can we draw from our findings, what are our recommendations, what are the limitations of our analysis. So when we look at components of a data analysis plan, the first component is the purpose of evaluation, which is normally linked to research objectives, and then the specific questions that operationalize the analysis of data. And then the other issue is, what do you hope to learn from the question or questions? And then the analytical techniques that are actually implemented. Some, they just end with descriptive statistical analysis and cross tabulations. Some go beyond descriptive statistical analysis and cross tabulations to chi-square testing and other forms of hypothesis testing. Some, they go even beyond that to discriminant analysis, principal components analysis, and so on. And then the researcher has to decide how data will be presented once analyzed. And then the common descriptive statistics, which I talked about in the previous slide, when I said in the previous section, when I said some may just prefer to just start and end with descriptive statistics. Some of the descriptive statistical analysis may be counts, which include frequencies, or which in most cases involve calculating frequencies, and then your percentage is your mean. That is your arithmetic mean, or different kinds of arithmetic mean. Your mode, your median, your range, your standard deviation as a measure of dispersion, your variance as a measure of dispersion, and your rank to facilitate the calculation of further statistics like your correlation coefficients and so on. And then how do you get your data ready when you are analyzing it, or as part of the process of analysis? First, you assign a unique identifier. A unique identifier is a code that you use in order to assist you make sense of the data when you are analyzing it and presenting it in form of graphs. Second, you organize and keep all forms. That is documents such as questionnaires, interview schedules, and testimonials in order to make sense of the responses that you obtained from the data gathering process. And then next, you check for completeness and accuracy. And then you remove those that are incomplete and or do not make sense. Because to analyze complete questionnaires or complete interview schedules or complete testimonials together with incomplete ones would otherwise distort your findings. And then the statistical software, the statistical software packages that are used, they include SPSS, which is the statistical software that I'm going to demonstrate. I've got a work file that I'm going to use of a study which was conducted in Hungary. and I'll just follow, certain aspects in the analysis of that work fine, up to hypothesis testing and regression analysis, so that I can demonstrate how we carry out certain aspects of analysis and how we mount a hypothesis and decide on different kinds of hypotheses depending on our research questions. And then we've got the Eviews. Eviews is specifically for econometric modeling. It does a lot of things, but it's purely for quantitative data, which is normally imported into the interface or mounted onto the interface through Microsoft Excel, the Microsoft Excel package, if I may put it that way, of the MS, the Microsoft Office sort of utility softwares. And then we've got Microsoft Excel itself, which is the primary, software that we use in order to come up with spreadsheets of our tabular data to enter into other softwares. And we also have PCQ. We've got Cretil, Stata, Shazam, MATLAB, Oxmetrics, and so on. But basically, for purposes of this course, we're going to look at SPSS and Eviews. In a future video, we may demonstrate either using PCQ or Stata or even Microsoft Excel itself, how you actually analyze data, or even Stata. In the past, I've analyzed data using Stata with the students that I taught econometrics, for instance. In 2016, there is a group that I taught advanced financial econometrics and data analysis. The students who were pursuing a master's degree in financial engineering. So the software that I was using was not Eviews. I was using Stata in order to demonstrate the data analytical components of that econometric course. So at a certain point in the future, I may actually also demonstrate how you actually analyze data using Stata. But for the purposes of this course, the software packages that I selected, which I believe are very simple to follow, are Eviews and the statistical package for social sciences, which is SPSS. In this course, we shall concentrate on SPSS and Eviews. SPSS is especially versatile because it can analyze both qualitative and quantitative data. SPSS can perform both categorical and ordinal analysis and regression analysis, just basic, simple regression analysis, as well as other quantitative tests. We know it has got limitations because it's based on the click kind of interface. When it comes to analysis, there's just basically very limited room when it comes to programming. But with Eviews, you can do quite a bit of programming in formulating specific equations and, introduce all sorts of, distributional assumptions to your various aspects of your models in order to come up, so as to come up with quite interesting models. Eviews is especially suitable for regression analysis and the diagnostic tests associated with regression analysis, as well as, statistical inference that is normally made from regression analysis. The statistical package or program for social sciences is software mostly used to analyze survey data. This type of software can also be used to analyze quantitative data, which is imported via Microsoft Excel. The software is a highly interactive syntax and dialog boxes that facilitate sorting, defining of variables. So basically, when opening SPSS, the default window will have the data edit. When you just click and open the SPSS software, the default window will have the data edit. And there are two sheets in the window. The first is the data view, which has been highlighted as yellow there. And then the second is the variable view, which is not highlighted. So the data view window, this sheet is visible when you first open the data edit, and the sheet contains the data. You click on the tab labeled variable view in order to see the kind of variables that you can enter, and then how you can actually do the quoting. This is the window that enables us to actually carry out the quoting process. You assign specific names which are legal according to, the way SPSS was actually programmed. There are some illegal names or characters there. For instance, to come up with hyphenated names is not permissible within SPSS. The names have to be continuous. And there are some names which are actually reserved within SPSS, which are not allowed. And then we move on. So when you click there, you get to see the variable view. And then under the variable view window, the sheet contains information about the data set that is sorted, that is stored within, about the data set that is stored within the data set, or about the data, just the data, which is stored within the data set. The name, the first character of the variable name must be alphabetic. Variable names must be unique and have to be less than 64 characters. That's one of the limitations in naming, your names. Spaces are not permitted, as I alluded to that point when I was explaining on the previous slide. And then the next part after naming the variable is the type. When you click on the type box, the two basic types of variables that you will be using are numeric and string. This column enables you to specify the type of variable. This is important when you are analyzing data later on. Generally, for survey information, it's either you are dealing with data which is numeric or data which is string. But there is comma designated data, and then there is dot designated data, scientific notation, date variables, dollar, and custom currencies as well. But basically, for the purposes of this course, we've got numeric and string variables. And then in terms of the width allows you to determine the number of characters SPSS will allow to be entered for the variable. So you specify those. And then the normal width is given as 8. You can adjust that. And then decimals, these are the number of decimal places that are allowed. It has to be less than or equal to 16. So you can have up to 16 decimal places to take care of maybe a 10 millionth or a millionth or a quintillionth of a variable, a quadrillionth of a variable. When you have 15 zeros after the comma before a number, it's a number in billions. Red would be in the range of billionth. So it's a very tiny number, billionth. So they are also accommodated within the statistical package for social sciences, or the statistical program for social sciences. For instance, you can have pi, and then after the comma, we know pi is 3 point something. You can have up to 16 decimal places. And then under the label, you then specify the details of the variable. You can write characters with spaces up to 256 characters. So these labels are the labels that will appear on your graphs, on your flow charts, and so on. That's what appears after you've analyzed the data. And then the values, when you click the cell in the values column as shown below, for the value and the label, you can put up to 60 characters. You can specify up to 60 characters. And then after defining the values, click Add and then click OK. It will be populated where it's highlighted none. Where it's highlighted none, now it will be defined in terms of 1 being male and 2 being female. For instance, how would you put the following information into SPSS? You've got Jaunita. She is female and has a height of 5.4. I believe these are inches. And then you've got Sally, 5 feet 4 inches. Sally, female again, 5 feet 3 inches. Donna, 5 feet 6 inches. Sabrina, a lady again, 5 feet 7 inches. And then you've got John, a short young man or boy, 5 feet 7 inches. And then you've got Mark, who happens to be 6 feet, almost 2 meters, around 2 meters. And then you've got Eric, who is more than 6 feet, and so on. So when you enter the information shown in the previous line, gender will be defined as 1 for male and 2 for female. And the height will be such that you don't specify it because you enter it in terms of what is written, your 5 feet 4 inches, your 5.3 feet, 5.6 feet, and so on. We may put it that way. And then after you've entered all of your variables, they will appear in the data view. You then enter this information after defining the variables, which is the quote. The variable view helps you to carry out the quote. And then the data view helps you to end. So once more, the variable view helps us to code for the information that we want to enter or that we want to either enter manually or enter through a Microsoft Excel or any spreadsheet from any spreadsheet program. We have to code for those variables. Otherwise, SPSS won't be able to make sense of what we are entering. And then after we've done that, to actually enter the information, we need to click the data view, where we can then enter Jaunita, the name, specific name. And then we click 2, which stands for female, and then we actually enter the height, which we didn't specify there, obviously, because we want to enter it manually. And after we've entered everyone, that's the schedule that will appear. And then to save the data file, you simply click File and click Save As. You can save the file in different formats by clicking Save Type As. There's so many, forms or formats in which we can save our data as a .sum file, SPSS 7.0.sum file, .16, dot comma delimited or delineated value, which is .csv, and so on. Or as an Excel kind of spreadsheet. SPSS is also capable of doing that. And then we can click data on the tabs that we see on top of the interface of SPSS. Under the data view, we are able to sort the cases either according to height, because when you look at the figures that are presented, you've got some females that are actually the same height as a certain man. You've got Sabrina and John having the same height. Sabrina is a lady and John is a man. So if we're grouping purely on the basis of height, then this thing is using the alphabet as well. You would have John appear among the ladies, so on and so forth. And then you would have Bruce appear before Mark and Eric. We have got a greater height than Bruce. So we can sort cases. We just double click name of the students and then click OK. You can sort students according to gender or sort students according to their height. We'll do this practically and you'll be in a position to understand how this is done in essence. You can see that Bruce is now number 1 because his name starts with the letter B, and then we move on to Donna, which is the letter D. Eric, Jaunita, John, Mark, and then ending with the 2 names that start with the letter S. This is regardless of the heights. Then how would you sort the data by the height of students in descending order? We will do that as an experiment, but basically you click data, sort cases, double click height of the students, and then click descending, and finally click OK, and then it will just sort out. That's it. So you can also click transform and then click compute variable. After you've done that, you will be able to add the natural log of height, which is the ln height. You can calculate the natural logarithm of the height. You type ln height in the target variable box and then type in ln brackets height in the numeric expression box. And then you click OK to command the software to calculate the natural logarithm of height. And then you click OK. So it will calculate the natural log of the height, which appears as the 4th column. So you can transform your previous data into a new variable, which can provide you with interesting features of the data that you are analyzing. And then you can create a new variable, which is the square of the height, or rather the square root, which is the square root of the height. You can come up with the square of the height, not the square root. Your height squared, for instance, if you need to square it in order to see or observe certain features, In this case, someone might say, I want to know the square root of the height. Again, what we do, the target variable will be coming up with the SQRT height square root. SQRT in brackets height is a command or the numeric expression which creates your 50 column there. 1, 2, 3, 4, 5. Your 50 column, which is the square root of the original height. Like your 6.4, 6.0, and so on. So the basic analysis of SPSS that will be introduced in this class includes your count or your frequency. This analysis produces frequency tables showing frequency counts and percentages of the individual variables, percentages of the values of the individual variables. And then we also have the descriptives. These descriptives, the analysis shows the maximum, minimum, mean, arithmetic mean, and standard deviation computed from the arithmetic mean of different kinds of variables. That would be of interest to the statistical analyst. And then you also have linear regression analysis, which estimates the coefficients of the linear equation under the basic assumptions of the best linear unbiased estimator, which is your blue characteristics of a simple linear model or a simple linear equation. And then when we open sample data, we can also use SPSS to actually analyze an existing, work file, an existing SPSS work file, not just to enter data. We just go to file, open, and then we click data. Then we are able to open that work file and then analyze it in terms of frequencies, or in terms of descriptive statistics, or in terms of cross tabulation, where basically you'll be pairing different kinds of variables and coming up with cross tabulations or PP plots or QQ plots or ratios and so on. If we click the gender variable and put it into the variable box, and then we click chance, we are able to come up with bar graphs or pie charts or histograms. And then we click continue. And then we are able to also display frequency tables by clicking OK. And then the software will calculate for us the valid number of cases and the missing cases. In this case, there were no missing cases. There were 474 members in this work file or respondents. And then it's telling you out of the 474, 216 were female and 258 were male. And then the percentage share of each group in the total sample was 45.6 for female and 54.4 for male. And then the valid percentage is just the same thing which you saw in the previous column. And the cumulative percentage for the female is 45.6 because they are the first ones in the group, plus 54.4 to give us 100% as the cumulative percentage for the male. Those who have added the female to get the cumulative percentage. And then the graphical or bar graph, method of data representation just shows us that the female respondents are fewer than the male ones. And then we can analyze descriptive statistics such as your mean and your standard deviation. And we also calculate the mean and the maximum value, the minimum and the maximum value. You can also look at your measure of kurtosis, which is the measure of pickedness, and the skewness, which is the measure of slant from the mesochatic distribution of data, either slanting to the left or slanting to the right. When you click continue, your software, your SPSS, will be able to analyze for you the statistic, which is the total number of elements, the minimum statistics, the maximum statistics, the arithmetic mean statistic in terms of education levels, beginning salary, and so on, whatever you might be interested in, your standard deviation, your variance, and your measure of kurtosis. And then we can also do regression analysis where we can come up with curve estimation, partial least squares, partial least squares, or binary logistic, the multinomial logistic regression model, the ordinary, the probit, the nonlinear weighted, estimation, and so on, as well as linear regression. And then the linear regression model is basically y is equal to beta 0 plus beta 1 x plus the error term. And then we come up with a simple model for that. So sal begin was your dependent variable, is your dependent variable, and your independent variable is level of educational attainment. Where your sal begin is beginning salary, and then edu is actually standing for educational level, the independent variable. When you calculate your regression model, we see that in terms of the parameters, the constant is negative. Constant is negative. Most probably because when someone's education is there, they won't be having any salary. They have to rely on others. But as their years of education increase, the relationship between educational attainment and beginning salary begins to be positive, or is expected to be positive. The more years of education they have, the higher the salary that they are likely to earn, ceteris paribus. Of course, there are standard deviations associated with those estimated parameters and the standardized beta coefficients, as well as your t-values, your student t-values, and also the significance probabilities, which are written in the last column as SIG. These are significance probabilities of the estimated parameters, your constant and your level of educational attainment. And then you can plot the regression line by clicking graphs, legacy, dialogues, interactive, and scatter plot from the main menu, which enables you to keep and get quite interesting graphs as well. When you input the current salary into the vertical axis box and the beginning salary in the horizontal, you click fit bar. Make sure the method is regression in the fit box, and then you click OK. You are able to have a graph like that, for instance. And then we move on to Eviews. It's actually econometric views. It is a statistical package for Microsoft Windows, a software program used mainly for time series oriented econometric analysis. It was initially developed by the Quantitative Microsoftware System, or company, now part of IHS. the IHS group. Version 1.0 was released in 1994 in March and replaced with micro TSP. The current version at the time when I was compiling these notes was version 8.0, but now we have got Eviews 12. So Eviews 8 is no longer the current version. We've got Eviews 12. Eviews can be used for general statistical analysis as well as econometric analysis of cross-sectional and panel data as well. The software has got an interesting graphical user interface. We open the Eviews window and then we create a work file, or we actually import data. But we can create a work file and then we edit and save data, we view and plot data, view summary statistics, generate new variables, and run simple regression. So most of what we are going to be doing, I'm going to demonstrate it by actually using the softwares themselves. So ladies and gentlemen, I believe that the brief exposition that I've given you, which dwelled more on the SPSS package, has served as an introduction to how we will analyze data. As for Eviews, I'm going to demonstrate practically how you analyze data within the context of Eviews. I believe that you benefited from this exposition about data analysis using mainly SPSS, but also Eviews, which will be used by some to analyze their data as part of your research project or your dissertation. Thank you so much for listening in. I appreciate you following my exposition. In the next lecture video, I'm going to demonstrate how you analyze a work file using SPSS. Thank you so much for listening in. Have a good day.